Okay, hello everyone. This is Professor Lei. Welcome back. So this video is for Chapter 6, Manufacturing Processes. All right. So in this course, we already talked about a few different topics. Okay, like forecasting, like inventory management, like the capacity management. Right. So the sequence of these different topics that we already talked about is exactly following the operations management process sequence. All right. So give you a quick sense about it, right? So probably before we even start to produce to sell, we first of all we need to have an understanding about the specific forecast of the market demand of this product or services, right? Before we can do some specific operations management planning, right? After by using let's say by using some sophisticated quantitative methods or qualitative methods, and that help us to get the forecasting of the market demand for your product. And then we start to think about basically how many inventory we need to prepare in order to fit for the market demand, right? That's why we do inventory management after the forecasting. All right. So after we do both of these two topics, the forecasting and the inventory, then as the firm, as the CEO, we need to further think about, okay, even if we have very sophisticated forecasting methods and we predict very well, and even if we have the very nice inventory management, right, we need to think about basically whether we have the enough ability or capability to maintain the inventory level, right? So that's why in chapter 4, we talk about capacity management, okay? So now let's move to chapter 6. So right now, let's say no matter the forecasting or the inventory management or the capacity management is already ready for you to produce, right? Then so the production process itself is also very important topic to discuss. That's why chapter 6 we will mainly talk about the manufacturing process. Okay, a lot of very important key points are included within this manufacturing process. That's actually the core, the core part within the whole operations management field. Okay, so now let's start to look at the main learning objectives of this chapter. All right. So first of all, at least we need to first understand what is a manufacturing process. All right. What are the key elements are included within the manufacturing process? Okay, this is quite important. And then we will try to understand, the production process mapping. I will introduce a few key elements within the mapping, the production process mapping, and why we need to include those key elements. All right. And then in order to quantify, those, let's say, inventory in process, all right, we have to apply certain, math rule like the Little's law that we will talk about just in a second, right? Uh, so that's actually so by using the Little's law, it's very helpful for us to at least have a sense about what is the working process inventory, how many materials, how many assets we have within the whole manufacturing process. Okay, so this would be a very important quantitative method. Okay, we will use a few different examples to help illustrate. All right, now after that we will start to explain how the manufacturing process are organized, what are different type of the manufacturing processes, how to deal with every type of the manufacturing process. All right, that's all we will talk about in this chapter. All right, and more specifically, let's say we're dealing with the assembly line production process, all right, and then how to design assembly line and how to effectively analyze assembly line. That'll be the last learning objective of this chapter. Okay, so you can see that actually the learning objective of this chapter is quite straightforward. All right, so let's start to talk about from the beginning. All right, now first of all, the production process itself is so in general it's quite simple. All right. So basically, as I show here, the production process, the target of the production process basically is just to make some, manufacturing product, right? That's basically the target of this whole process. All right. But in this whole process, typically we can separate into three steps. All right, as I show here. So in the first step, basically, we need to source the parts needed, right? basically, if I want to produce this product, okay, I need to consider what kind of the raw material or what kind of parts that I really need in order to get the final product, right? So that's why, first of all, even before we produce, even before we do some other operations management things. First of all, we need to kind of understand what are the raw materials that we really need in order to get a finished product. All right, and where and when I can get those raw materials. Okay, that's all included within step one. So you need to source the parts needed or source the raw material you need. All right, and after you get the let's say the parts, no matter the parts or the raw materials from your supplier, let's say the supplier. All right, and then okay, you already finished step one of the production process. Okay, that's the fundamental step, but also very necessary and important, right? So that's actually very simple. All right, now once you basically set up the step one, once you finish step one, we move to step two. Okay, after you already get all of the necessary raw material, all right, for the finished product, you move to the step two and start to make your products within, let's say, the production line by machine or even by labor or monitor by labor. All right, so that's actually including step two. So basically, step two is the making product step. All right. So in this step, basically, you do the things you combine different parts or you use the different raw materials in order to get the finished product. All right. So that's the step two. Okay, very intuitive. And then after you make the the specific finished product, all right, then you move to the step three, right? Because after you make the finished product, you cannot sell it directly because you are still in your factory, right? So basically, you have to deliver your product to, let's say, a retail store or some, display, at least some display table, such that the customer can see it and they can buy it from, let's say the retail store. All right. So that's why in general we have these three steps. All right. First of all, you need to source the raw material and parts, and then in step two, we make the product in the production line, and then in step three, okay, after we produce it, we deliver it to the customers. Okay. So this will be the very general steps. So this is quite intuitive. All right. And that's why here, basically, in this plot, this is quite simple, right? Source it, make it, and deliver it. That's it. That's a production process. All right. So later on, we will separate into four different specific type of production process. All right. Either make to stock, assemble to order, make to order, and engineer to order. All right. So I will detail talk about every type just in a second. All right. But right now, just let you know that actually, depending on when customer can see the product, all right, or when the customer can participate in the product, actually we can separate into different type of the production process. We'll detail talk about it just in a second. All right. Now, before we talk about the basically the specific type of the production process, okay, we have to introduce a few different concepts. All right, because those concepts are used in order to differentiate different type of the production process. Okay. So the first concept basically is lead time. Actually, I think all of you guys should already know lead time, what lead time it is, right? So remember that actually in chapter, I think in chapter 11, when we talk about inventory management, right? We talk about the lead time. When we talk about the fixed, let's say the fixed time period model, right? When we introduce the quantity method for inventory management, especially for fixed time period model, we talk about lead time, right? So what is the lead time? The lead time is quite simple. Basically, lead time basically is just the time needed to respond to a customer order. All right. So basically, sometimes let's say if we do not actually have this specific, let's say product in the retail store, it probably needs some time to transit from the factory to the retail store. Or sometimes for other type of products, all right. So for the customer, they have to wait until this product is already made, right? And then it will come to the customer. So lead time basically is just the waiting time for this customer to get this product. Okay, basically it's the time between order and delivery. All right, so that's the lead time. Very simple. All right. Now, the second concept is quite important, especially to differentiate 4 different types of production process. It's called customer order decoupling point. Okay, customer order decoupling point. Okay, the intuition inside is quite simple. All right. So here you see that what is the definition here? Definition basically means that definition basically tells you customer order decoupling point is where the inventory is positioned to allow entities in the supply chain to operate independently. Okay, so you see that basically the customer order decoupling points tell you that basically for this specific type of product, right, when the customer can see or participate in the production process. Okay, so different type of products may actually have the different, you can see or you can participate in a different stage. That's why we separated this production process into different types. All right. So we will also still detailedly talk about the customer order decoupling point when we move to the specific type of the production process. Okay, so here just to give you a quick sense about what is the customer order decoupling point. All right, now the next one would be lean manufacturing. Okay, what is lean manufacturing? Very simple. Lean manufacturing basically is aiming to achieve high enough level of customer service with minimum inventory investment. Okay, so basically the key point for lean manufacturing is that you are trying to use the at least as possible inventory investment in order to achieve the highest level of customer service. Okay, so if I can achieve the lean manufacturing, that will be the most efficient way for your manufacturing process, right? Because you can already achieve the high level of the customer service, but with the very low cost from the inventory holding, right? From the holding those inventory, right? But everything has its trade-off, right? Here, if we try to use let's say we incur as little as possible for the inventory holding cost, but in order to achieve the highest level of customer service, okay? So this all only fit for the situation that you can predict, all right, your market demand very accurately, right? So if I can predict the market demand very accurately, then I only produce the amount that the market demand needs, right? And then send to the retail store, and then the customer will buy it. But sometimes in the real cases, right, it's very, very hard to accurately predict, how many products or how much services actually the customer really need for this specific product for this type of service, right? That's why here we really need inventory. Okay, so lean manufacturing is very attractive if we can predict the market demand very precisely. Okay, so because actually we can minimize our inventory costs, but we can achieve the highest level of customer service. That will maximize our profit as a firm, right? But in the real case, the reason that we still wanted to hold inventory is to prevent the risk of outstock, right? Because we don't want to actually have the situation that the customer comes, but we don't have this product, then maybe we will lose this profit opportunity. That's the reason that we prepared inventory. All right. So, but here, just give you some sense about what is a lean manufacturing. All right. Now, after we introduce the 3 different concepts, then we move to the types of firm. Okay. So basically, we separate into 4 different types, right? These 4 different types of firm are classified by 4 different type of production process. Okay. Remember, we just talked about the customer order decoupling point, right? So here, I will apply the customer order decoupling point in order to illustrate these 4 different types. All right. So before we actually specifically talk about every type of firm I listed here, okay, just give you some quick sense and broad sense about the difference among different type of firms. All right. So first of all, the first type of the firms is called make to stock. Okay, make to stock. So basically, when customer look at the product, it's already become the finished product. All right. Let me make it clear. As a product, all right, it may be in the raw material stage. Okay, it may be in the work in process stage, or it may be in the finished product stage. Okay, so product can be in general can be in these 3 stages. Okay, but for make to stock firm, customer can only see products when it is already at the finished product stage. Okay, that's actually very important. That's why here the definition for make to stock is to basically serve the customer on the demand from finished goods inventory. Okay, because when the customers see this product, you already become the finished goods. Okay, you will not see this product when it is at the working process stage or when it's actually in the raw material stage, preparation stage. All right. Now, the second step is called assemble to order. Okay, what it means assemble to order type of firm? Basically, if the firm combine a number of pre-assembled modules, okay, in order to meet the customer specifications, then we say, okay, this firm is basically classified as assemble to order firm. Okay, so if I back to the thing that I just mentioned, all right, 3 stages: raw material stage, okay, raw material inventory, work in process, inventory or work in process stage, or the finished product stage. All right, which stage do you think that the customer can see this product? Okay, for assemble to order firm or assemble to order type. Which stage? The answer is very clear, right? The answer would be work in process stage. Because basically, when you look at the product, okay, it will tell you that basically you haven't produced, right? But some different parts already ready for you to pick up, right? And then they will tell you, okay, for this part, how many options you have. For that part, how many options you have. For the last part, how many options you have, right? And then you pick up the favorite one that you like for that specific part, and then okay, tell them your choices, and they will combine with each other in order to give you the finished product that you want. Okay, so for this type of the firm, we call it assemble to order products. Assemble to order firm. Okay, so specifically, for customers for this type of the firm, customer can see products at the working process stage. Okay, at the working process stage. All right, now the last one, basically last two would be make to order or engineer to order. Okay, the very specific separate into make to order and or engineer to order. But actually, for these two different types, the key sense is very similar. So we can, in general, we can basically combine these two types of the firms into one type. Okay, make to order and engineer to order. Okay, let's look at the key sense of the make to order or engineer to order type of the firm. Okay, so first of all, for make to order type of firm, it says that basically what kind of firm can be classified as make to order firms. Basically, these are representing the firms that are making the customer product from raw materials, parts, and components. Right. So more specific, basically, when customer look at this. When customer can see this product, all right, this product is still at the raw material stage, okay? Or let's say for engineer to order type of firm, right? Basically, the customer even participate and work with the factory in order to design and then make the product. Okay, so basically, in general, no matter make to order type of firm or engineer to order type of firm, customer can see or can participate, okay, when this product is still at the raw material, or we say the preparation stage, which is basically the first stage of this product. Okay, so you see that actually when we compare, let's say the make to stock, okay, and assemble to order, okay, and the last two type of firms, you see that actually the key difference among these different type of firms, okay, in terms of the production process of this product, all right, is that basically is when this customer can see or when this customer can participate, okay, for this specific, in order to get this specific product, right? If the customer, when the customer can see this product already becomes a finished product, all right, finished goods, probably would be the make to stock type of firm, all right. But for other situations, all right, if this customer can see or can even participate to decide this product when this product is still at the assembly stage, this is called assemble to order. Okay, but if this product, all right, when customer can see or when customer can see or participate for this specific type of product, when this product is still as the preparation, or as the let's say the raw material stage, then we say, okay, this could be classified into the make to order or engineer to order. Okay, we will use a different example to further illustrate these four different type of firms. Okay, but here just give you a quick sense about the differences of the different type of firm in terms of the production process. All right, of course we can separate firms into many different types based on different criteria. Here, based on the production process, okay, we can separate these firms into these four different types, or in general, we can separate into three types: make to stock, assembly to order, make to order, and engineer to order. They're actually quite similar. All right, now let's detailedly talk about every different type of firm. All right, first of all, make to stock. Okay, you may still remember that. First of all, for make to stock type of firm, right? Basically, the product will serve customers, from the finished good inventory format, right? So that would be the make to stock type of firm. Okay, you can even imagine what type of the product actually is very fit for the make to stock type of firm, right? So here are at least some of the examples. Let's say those type of divisions, or clothing or packaged, food products. Okay, give you a quick example. Let's say you work into the Zara, right? So on the display table, there are there are different type of the clothes showing in front of you. All right, and you can look at this one, you can compare to another one, and finally decide which one you like. All right, but no matter which one is displaying there, all right, all of those products are finished products, right? That's why here, for those type of the firm, okay, especially let's say Zara in this example, okay, this is the make to stock type of the firm, or type of the product more specifically. All right, so but we know that if you can DIY, or if you can customize a clothes for yourself, then suddenly, all right, for this type of product, the type already changes. Okay, you can even imagine what type of the corresponding product this is corresponding to. If you can DIY, if you can even customize this clothes, let's say the pattern, okay, showing on the clothes, all right, then this is not a make to stock type of the product. All right, it will become which type of product? Think about this. It will become engineer to order, because you can even participate to design, the product itself, right? So basically, you can talk to let's say the designer, okay, and tell them which type of the pattern, what kind of pattern you want, what kind of color you want. All right, and then the designer, after get this information, they will try to achieve it. They will try to to make that pattern in front of these clothes and give it to you. So you see that actually when for that specific case, right, customer can participate in production of this products when this product is still as the, let's say, as the preparation stage, right? That's why here still for clothing example, here if we work into Zara and directly pick up the clothes, this is make to stock products. All right, but if you can DIY, let's say a clothes for yourself, then that would actually belong to engineer to order type of the product. Okay, so that's different. Even if in both cases, we are talking about is just clothes. Okay, but the key sense here is different. Okay, the key idea here basically is when this customer can see, or when this customer can even participate, for this product in the production process. Okay, that's the key point here. All right, now, so that's why here the essential, as I said, the essential issue basically satisfying customers to balance the level of inventory against the level of customer service. Okay, so the reason here for this specific type of the product, make to stock product, right? You don't actually want to, put too many inventory in your retail store, okay? Because that will cost you more holding costs, that will cost you more setup costs, okay? That's the thing that you want to kind of, you don't want to eliminate, but you want to, make it as small as possible, okay? Based on the situation that you still can fit for all of the market demand, right? Yeah. So That's why here you see the lean manufacturing, right? We just talked about lean manufacturing. You are trying to achieve the high service level by minimizing the inventory cost. Okay, but that's the ideal situation. All right. In the real cases, our final goal is to reach the lean manufacturing. If we can predict the market demand very precisely, but it's really really hard, even impossible to very precisely predict the the market demand. That's why here we always put some inventory as the buffer, All right. Now let's move to assemble to order. So assemble to order type of product is different. All right. Okay. So for the assemble to order product, basically the customer, they can pick up the part they would like, and then the firm will will combine all those different parts together in order to get the finished product. Okay, that's a key characteristic of assemble to order products. All right. So that's why here you see the primary task basically is to define customer order in terms of alternative components since they are carried in inventory. Okay, so basically the inventory that the firm is carrying is not the finished product, okay, but the components. Okay, the components are ready in the warehouse of the factory. All right, but the factory will not hold the finished product directly. Okay, think about why for certain type of the products, okay, the factory or the firm would more prefer to hold the components instead of the finished product in the factory. Think about this. What is the reasoning behind? Okay, give you a quick example. All right, one very typical example of the assemble to order product is the computer. Okay, think about the computer. Computer probably will have a few different components, right? Let's say the screen, let's say the keyboard, let's say the hard drive, let's say the CPU. These are all different parts, right? But let's say for Dell company, for Apple company, okay, normally they will not hold the finished product. Let's say the final laptop, or the computer here in their factory. They will not do that. Instead, they will only store the components. Let's say different type of the screen, different type of the keyboard, different type of CPU, or different type of let's say the hard drive in their factory. Why? What is the logic behind? All right. Here I give you a quick sense about it. All right. So give you a quick example. All right. Let's say I just use this space to write it down. All right. Let's say we only talk about three different parts. All right. We only talk about, let's say, hard drive. Okay. Hard drive. Let's say CPU and also the screen. Okay. So as a firm, if I tell you that for our product, okay, let's say we have three options for hard drive. Okay, we have three options for hard drive. Okay, let's say we have four options for CPU. Okay, we have four different CPU. All right, and for screen, let's say we have two different type of screen. Okay, so let's say you are a customer, right? No matter you walk in the retail store or you want to buy it online. Okay, if you go to, let's say you go to the official website, okay, and you want to, let's say, buy a Dell computer. All right, right now you walk into their Dell computer's official website and they tell you that for, let's say, for this type, we have three options for hard drive, we have four options for CPU, and we have two options for screen. Okay, and normally you just, let's say, for hard drive you pick up the one that you like it most, right? That's also true for CPU and also for screen. Okay, but let me ask you a question. As the firm, if I try to prepare the finished product, okay, how many different finished products actually we can have by having three different options of hard drive, four options of CPU, and two options of screen? How many different combinations? Okay, think about this. Okay, so here This is the corresponding equation to help you get the combination number. Okay, if you have 3 options for hard drive, 4 options of CPU, and 2 options of screen. Okay, yeah. So first of all, we make it very clear. Even if you have the same hard drive, but if the CPU and the screen is different, then it's a different finished product, right? That's not exactly the same. Okay, the product is exactly the same only when the hard drive, the CPU, the screen, all these parts are same. Then we can say this is the same product. Otherwise, it's different. Okay, but how many different possible combinations that we can have? Okay, let's say within this example, how many? How to count this? You see n1 times n2 times n minus 1 times n. All right. So in this quick example, to basically apply this equation, how to apply this? Very simple. Use 3 times 4 times 2, right? Because since you have 3 options for hard drive, you have 4 options for CPU, and you have 2 options for screen, right? So in total, basically, the combination number would be 3 times 4 times 2. That's the whole number for possible combinations, all right? So 3 times 4 times 2 would be 24. 24 means what? You can have 24 possible combinations, right, for your finished product. Think about this. If the Dell company, if they prepare all these 24 different combinations, all right, that would take that would take a lot of space, right? First of all, right, and they cannot exactly predict for each type of this possible combination what is market demand for that, right? So that will actually take much effort, and basically they will also they will increase their cost during this production process. That's why for this certain type of the product, okay, instead of actually preparing the finished product, okay, the company would always prefer to just store the different components or different parts in their factory, okay, and then when the customer, let's say, order it on the website, okay, after the customer pick up the specific part type that they want for each component, all right, after they order it, the factory will get this order, and then they start to assemble different parts very quickly, all right, and then it will send to the customer actually very quickly by having a lead time, right? Because it may still take a few days or maybe a few weeks before the product can transit to the customer. Okay, so that's would be the reason. So here you see only even if we only have 3 options for hard drive, 4 options for CPU, or 2 options for screen, you already have 24 combination for finished product, right? But if we know that for a computer, this is not just hard drive, CPU, or screen. We also have the keyboard. We also have the other, let's say, for others different type of the components, right? And the option for every different component is more than 3 or 4 or 2. Sometimes it may be even 10 or 12. You see, so that basically the combination of different of the finished product can be very large number. Okay, so in order to prepare every possible finished product combination is very, very costly, and actually the company cannot predict the market demand for that specific combination. Okay, that's the key point why for this type of product the company will not actually inventory the finished product. They will inventory what? They will inventory basically the component. Okay, so that's the key point for assemble to order. Let's make it very clear. Okay, now the last general type is called make to order, or we say engineer to order. Okay, as I said at the beginning, all right, no matter it's make to order or engineer to order, the key point here is that basically the customer can see or can participate, the production process. The production process of this product when this product is at what stage? This product is at the raw material or even at the design stage. Okay, that's the key point for make to order or engineer to order. Okay, so is there any real example for make to order or engineer to order? Okay, I already talked about one example, right? So just about the DIY the clothing or DIY or customize some product, right? If you want to DIY some product, if the firm allow you to do that, if the firm has this ability, for you to DIY, for you to customize certain products, then of course, right, all those different, no matter what type of the products, right, from in terms of the production process, it should belong to the make to order or engineer to order type of the firm or type of the product. All right. So here, I already talked about the clothes example. If you can DIY the pattern of the clothes, of course, for that specific product, it should belong to engineer to order type of the product. All right. Here, I give you another example. All right. Let's say for Boeing manufacturing process. All right. When Boeing before Boeing manufactured the airplane for, let's say, for a specific customer, all right, they may actually talk to the customer. The customer will tell what is their requirements for the outside, for the outside shape, and for the inside, let's say the furniture or some other details, right? And as long as the Boeing company can fit it, as long as the Boeing company has the ability to, fit the customer's requirement, right? They will make it after, gets the information about the customer's requirement. All right. So you see that actually for the customer, they can even participate the design of this specific product, which is the airplane, right? Or they can at least see the whole production process, right? And they can, let's say, do some DIY thing. Let's say they can use their favorite color for the outside, airplane shape, right? So you see that basically, once the customer can participate as the preparation stage or as the design stage, it should belong to the make to order or engineer to order type of the product or type of firm. All right. So that's why here I also say that customer order decoupling point could be in either raw material at the manufacturing site or the supply inventory. It's basically the customer order decoupling point is at the very first stage of this product in the production process. Okay, that's quite important. That's why here you see, actually, when we classify firm in terms of the production process, the customer order decoupling point makes a very important role, right? If the customer order decoupling point is at the, let's say, the finished product stage, okay, the finished product stage, it belongs to make to stock. It belongs to make to stock, this type of the product. All right. If this customer order decoupling point, all right, is at the, let's say, the working process product, it is actually at the working process stage, then we say, okay, for this type of product, it belongs to assemble to order stage. Assemble to order product. All right. And if basically the customer order decoupling point is at the preparation stage, is at the raw material stage, is at the design stage, then we say, okay, for those type of the products, they belong to make to order or engineer to order product. Okay, that's the key point. What I'm showing here. Okay, I think the intuition here is quite straightforward. Okay, just make sure that you understand what is the customer decoupling point. That's the most important thing. All right. Now, let's move to the production process mapping. All right. So, yeah, this is actually a very simple, flow chart about the production process. Okay, so you see that at the beginning, supplier will provide some source and then move it to it translate it to the factory, right? The reason here, you see, here's a buffer called raw material, right? So basically, of course, all of the source is actually coming from the supplier, okay? But it doesn't mean that the factory will not actually store some raw material in their factory, okay? Okay, the reason is very simple. Let me give you a quick sense about it, all right? As a factory, normally we will use the raw material in order to produce for the finished product, right? So let's say if we are actually producing this product, right? If the raw material itself is not enough, then what will happen? We'll get interrupted, right? Because there's not enough raw material, then the production line cannot produce any finished product anymore, right? They will be interrupted until the new raw material will actually come from supplier. Okay, so that's why here as a factory, they always will put some actual raw material within the let's say the warehouse. All right, in order to prevent that, they really needs those raw material, but the raw material is not ready. Okay, because the raw material from the supplier still takes some time, before they can actually reach to the factory. All right, even if the factory orders some raw material, right, supplier still needs, let's say, use a truck, use the airplane, use train to transit, the raw material from their factory, the supplier factory, to the, let's say this retailer's factory, all right, or manufacturers, more specific, the manufacturer's factory, all right. So that's why here the buffer of the raw material itself is very important. Okay, so here you see that there's another buffer called finished goods product, finished goods buffer. Okay, why we also need the buffer for finished goods? Why we actually need that? The reason is very simple. Okay, so first of all, as let's say as a manufacturer, all right, after you produce the finished product, all right, you probably will send it to the retail store. Okay, and then the customer will walk into the retail store and pick up the one they like. Okay, that would be a very standard process. All right, but here, all right, we know that actually the market demand from the customer is fluctuated always, right? So let's say for specific mouse, all right, if the market demand increases a lot, and if the factory cannot, predict it accurately, all right, so based on their operations, based on their production speed, they may not be able to, achieve, or they may not be able to basically reach that point very efficiently, right? Reach that amount very efficiently. Okay, in order to prevent the losing the profit opportunity, that's why for a factory, all right, normally they will produce a little bit more than necessary. Okay, so for example, for this month, let's say if the market demand for this specific product is, let's say, 1,000 units, probably the factory will produce, let's say, 1,100 units. Okay, so for this 100 extra units, okay, of course, this will not be sold in this specific month, all right, but they still want to, produce this 100 more, okay, and keep it in the retail store. Keep it in the warehouse. The reason is that, let's say for the next month, all right, if the market demand actually increases to, let's say, 1,200, okay, but if the factory can only produce 1,100, they can use that 100 inventory, okay, to compensate this gap, okay, in order to prevent the profit opportunity will go on. Okay, so that's the reason here. Besides the buffer for raw material, here we also have the buffer for the finished product. Okay, yeah. So here again, the buffer for raw material basically is to help factory have enough raw material to produce the finished product. All right, and the buffer for finished product basically is to help mitigate the pressure. Okay, if the from the factory, if the let's say the market demand becomes very good, okay, and if the factory cannot produce those amounts of the product, they can use this buffer to compensate the gap. Okay, so that would be the reason here. Okay, now we talk about this flow, starting from supplier to make process, manufacturing process, and then come to the delivery process. Okay, so this is a very general production flow. Okay, probably will happen in all of those type of the manufacturing firms. All right, but here, in order to quantify, okay, how many working process inventory that actually we are having, right? We actually need to use some mathematical equation called Little's law here. All right, remember, for the inventory, as I said, okay, it's not just the finished product inventory is the inventory. No, inventory itself actually has incorporated many different types. All right, of course, finished product inventory is one type of inventory. It's one of the most important type of inventory. All right, because your final goal basically is to make this finished product and then basically sell it to the market. Okay, that's your final goal. All right, but besides that, the working process inventory is also one important inventory, right? Although for this type of working process inventory, they are not ready for sale, but that's also the asset for the firm That's also the thing that actually, although this is not 100%, ready for sale, this is also the asset. This is also the important inventory that's within your factory. Okay, and then if we move back, the raw material is also very important inventory. Okay, the raw material we normally call it raw material inventory. All right. So if you're a major in accounting, you probably are more familiar with these three things, right? Inventory, first of all, is a very important asset showing in the balance sheet. Okay, and no matter it's raw material or is work in process inventory or finished product inventory, all those things are counted as inventory. Okay, but let's say in this production process, how we can calculate, okay, how we can calculate basically the amount of work in process inventory. How can we do that? That's why here we use this Little's law. Okay, Little's law. Let me give you a quick sense about Little's law. Little's law actually is a very important mathematical equation. Okay, so later on I will talk about Little's law. The sense, the general principle is quite simple. All right, but actually it takes many years for the mathematician, for those smart guys, to come out this famous equation. And this Little's law actually is widely applied in many different aspects. Okay, it's applied in physics, in mathematics, in economics, and also specifically also used in our operations management field. Okay, so it's a very widely used mathematical equation. Okay, so let me give you a sense about Little's law. All right, so what is Little's law? So apply to our context. All right, Little's law basically tell you that the inventory amount equals to the throughput rate times the flow time. Okay, first of all, what is inventory? Basically, inventory, as I say, show here, inventory basically those materials held by the firm for future use, right? Future use. So more specifically, okay, the inventory within this equation, let me make it clear. The inventory within this equation is basically the working process inventory. Okay, this is representing working process inventory. But as I said, the inventory itself, okay, has many different types, right? Raw material inventory are inventory. Working process inventory are one type of inventory. Finished product inventory also is accounted as one type of inventory, right? Here, by using Little's law, it will help you quantify the working process inventory. Okay, keep that in mind. That's actually very important. All right, now, what is throughput rate? The throughput rate basically is the average rate of flow through this production process. That's called throughput rate. Okay, what is the flow time? Basically, the flow time means for a single unit, okay, how much time it needs before actually from the starting point to the ending point. Okay, for unit product, it goes through this production process. All right, how much time it would need to go from the starting point to the end of it. All right, that's called flow time. Okay, let me give you a quick and also intuitive sense about this equation. Okay, inventory basically is viewed as how much or how many, okay, of the inventory you have in this production process. Okay, what is the throughput rate? Throughput rate basically represents how fast, okay, how fast actually this inventory is going through this flow time. Okay, that's the speed basically. All right, what is the flow time? Flow time basically is how much time you actually for this product, okay, in order to go through this production line, go through this production process. Okay, so basically conceptually, this equation tell you amount equals to the speed times what? Times the time. Okay, so on the left hand side of this equation, it actually represents the amount. Okay, the specific amount. At the right hand side, this one represents the speed. How fast? What is the speed? Of this production process, right? The flow time tells you how much time for a specific product will go from the starting point until the end in this production process. All right, so that's why conceptually or essentially this equation will be amount equals to speed times the time. Okay, and if we apply to this context, all right, inventory context or production process context, of course, inventory basically the amount represents the inventory amount. All right, the flow time basically represents the time for a unit to to go through this entire process, and the throughput rate basically tells you the rate of the flow through the process. Okay, so that would be the Little's law. All right, now I will use two different examples to illustrate Little's law. All right, if you are still a little bit confused about it, don't worry. I will use the specific example to help you get a deeper understanding about it. Okay, but before we move to the specific exercises, let me give you a few different things. Okay, that you need to understand. All right, first of all, the total average value of inventory. As I said, inventory has different types, right? Raw material inventory is one type of inventory. Work in process inventory is one type of inventory. Finished good inventory is also another one type of inventory. All right, so that's why here you see if we want to calculate the total value of the inventory, it should be the sum of the value of the raw material, work in process, or finished goods inventory. Okay, so suppose in a question, if I tell you that actually the work in process, let's say if I tell you the finished goods inventory is how much, all right, and if I give you some information for you to calculate the work in process inventory, and then if I ask you what is the total, let's say, amount of inventory, or what is the total dollar value of the inventory, you should, you should do some calculation basically, right? Because no matter it's raw material, work in process, or for finished, goods inventory, or those actually are classified as one type of inventory. You need to be very clear about it. That's actually very important. All right. Now the second one is inventory turnover. All right. So you should actually still have remembered this concept, right? Because in chapter 11, when we talk about inventory, we already talk about inventory turnover, right? If you are still a little bit confused about it, don't worry. Go back to chapter 3 video. I detailedly talk about what is inventory turnover. All right. So basically here, I would like to repeat it again. All right. So inventory turnover itself basically helps you to measure how efficiently this inventory can transform to basically the sales of this product. Okay. Because inventory basically are those products that you are not sell. You are not. You haven't sold right now, right? You haven't sold right now, but our final goal basically is to make those inventory sell to the customer. Okay, that's the final goal for the firm, right? So inventory turnover basically help you to help to measure how efficient this whole process is doing, right? That's why here when we calculate inventory turnover, we use the cost of goods sold divided by the average inventory value. Okay, to measure how efficiently this product is sold to the market. Okay, that's actually very important. And after we get inventory turnover value, if you take the if you do this calculation, use 1 over the specific value. Okay, if you do the inverse value, let's say the inverse of the inventory turnover, okay, that's actually corresponding to another concept which is called days of supply. Okay, days of supply, basically how many days you will need to sell this product. All right, so that's why days of supply basically just the inverse value of the inventory turnover scaled by days. That's it. All right, so after you calculate inventory turnover, you do the inverse calculation. Okay, according to the inventory turnover, you get the corresponding days of supply. Very straightforward. All right, now after we introduce this a few different related concept, let's start to go through our class exercise, which is corresponding to the Little's law. How we apply Little's law in our production process, which is very, very important. Now let's look at this first class exercise. First of all, let me briefly go through the whole context. An automobile company assemble cars in a plant and purchase batteries from a vendor in China. All right. The average cost of each battery is $45. Okay, $45. So the automobile company takes ownership of the batteries. When they arrive at the plant, it takes exactly 12 hours to make a car in the plant. Okay, this is the key information here. All right, and the plant assembles 200 cars per 8-hour shift. Okay, now we assume the plant operates one shift per day. Okay, and then each car uses one battery. Okay, that's probably true, right? And then the company holds on average 8,000 batteries in raw material inventory at the plant as a buffer. okay, as a buffer. All right, now you see that these are all the information that we have. Right now, we are trying to calculate, all right, what is the total number of the batteries in the plant, okay, and how much are these batteries worth, okay? So basically, you see, these are two questions here. So in order to get the dollar amount of this battery worth, then basically we first need to calculate how many batteries we have in total. Okay, how many batteries we have in total as inventory. Okay, as inventory. So you see here, we say in working process, no matter it's working process or raw material, it should be counted. Okay, it should be counted. As I said, inventory can be separated into different types, right? Raw material inventory, work in process inventory, or finished product inventory. All those inventories are inventories. Okay, can be classified as one type of inventory. All right, now, in order to calculate this, okay, of course, in this, by just looking at this information, you can already feel that we need to use the Little's law. All right, but in order to calculate the whole thing, all right, first of all, let me ask you first question. Okay, we know that actually the whole solution is shown here. Okay, but let me help you go through the whole process. Okay, first of all, in order to calculate total number of battery, right? We know that for this specific question, okay, the inventory of battery itself, okay, actually has two different, let's say, two different formats or two different types. One is work in process at the plant, and another type is raw material inventory. Okay, so first of all, actually, the contents already tell you that yes, they have the raw material inventory, and the amount of the raw material inventory is 8,000. Okay, normally if I don't tell you some information, let's say here, we don't actually tell you some information about the finished product inventory. Okay, that basically we just assume that basically right now the finished product inventory is 0. Okay, so we don't count it. But here, since we already talked about the raw material inventory, and I already tell you the information about the raw material inventory, so basically this 8,000 barrels are already, you see, 8,000 barrels, okay, also need to be counted as part of the inventory. Okay, so you already know this value directly. Okay, if I also directly tell you what is the work in process inventory, then you just do the simple addition, right? If I tell you that we have 10,000 batteries in work in process, then what is the final inventory? You use 10,000 plus 8,000, which is 18,000. That's it, right? Very simple. But here, it seems that I don't directly tell you what is the work in process inventory. That's why you need to do some calculation by using which equation? Exactly, by using the Little's law equation. Okay, now that's basically the logic here. In order to calculate the work in process inventory, okay, in order to calculate work in process inventory, remember for work in process inventory, you need to know the throughput rate and also the flow time, right? And then do the multiplication. Okay, do I tell you the throughput rate? Think about this. In general, in principle, all right, the throughput rate is represented what? It's represented how fast, right? It's representing how fast this product is going through this production line, right? Do we have any information about the speed of the production line? Yes, we have. Right here, the plant assembled 200 cars per 8 hours. Okay, 200 cars per 8 hours. Per 8-hour shift, right? That's basically telling you, okay, the speed, right, is how many cars we can produce in how many hours. Okay, that's basically telling you how fast we can produce for cars, right? That's actually very intuitive. That's right. Here, the throughput rate basically just the 200 cars per 8 hours. Okay, but remember here, when we try to basically calculate the throughput rate, right? We already know that throughput rate is 200 cars per 8 hours. And then we do some transformation. Why? Because this is per 8-hour shift. Okay? This is not a very standard or normal unit. Okay? So this is a cars per 8-hour shift. Then, of course, what is the corresponding number for cars per hour, per 1 hour? All right? 200 cars per 8 hour. then it's equivalent to 25 cars per hour, right? Basically, just use 200 divided by 8. That would be the corresponding number for cars per hour, right? 25 cars per hour. And since remember, here we assume that basically for every car, it has one battery, right? Each car uses one battery, okay? That's why here, 25 cars per hour is equivalent to 25 batteries per hour. Why we actually transform from car to battery? Because we are actually asking the question about battery, not car, right? So that's why here, since each car has one battery, that's why here the 25 cars per hour is equivalent to 25 batteries per hour. Now, in this case, this is exactly right. All right, but instead of actually, let me change just one thing. Okay, if I am talking about not battery, okay, if I'm talking about tire, okay, if I'm talking about tire for a car, all right, then normally, if I get 25 cars per hour, okay, it's equivalent to how many tire per hour? For your production process, it's actually equivalent to 25 times 4 because every car needs 4 tires, right? Here, each car has one battery. That's why 25 cars per hour is basically represent 25 batteries per hour, right? But here, if I'm talking about a tire instead of battery, then if I can produce 25 cars per hour, it represents okay. Then you can produce 100 tires per hour. Okay, so keep in mind everything needs to be logical. All right, here one car represents needs one battery. That's why these two numbers are equivalent. All right, because 25 times 1 is 25. Okay, but if I'm talking about tire, you should use 25 times 4 because we assume basically every car has 4 tire. All right, so that's why this is a super rate. Okay, 25 batteries per hour tell you the speed, tell you how fast this production process for battery. All right, now, but just having speed is not enough because we want to get the working process inventory, right? We also need the flow time. What is the flow time information? The flow time information is here. It takes exactly 12 hours to make a car, right? That's the time. Oh, sorry. That's exactly the time information, right? 12 hours, right? So that's why here, exactly 12 hours, okay? As I said, when we do calculation for throughput rate, one reason for us to transfer from 200 car per hour to 25 car per hour is that this is not a standard unit. Another important reason here is that you see we have to make this. This is per hour, right? This is hour. These two things has to be correspondent to each other. Okay, you cannot do something like this unit is battery per, let's say, per day, and then this is hour. You cannot directly do calculation between these two units, right? Battery per hour can times the hour, all right? Battery per day cannot directly time hour. You have to do the transformation before you can do the simple calculation. All right, here you see 25 batteries per hour, and their flow time is 12 hours. That's why you see when we calculate working process inventory, you directly use the 25 batteries per hour times the 12 hours to get this 300 batteries. That's it. Very simple. You do a very simple calculation. 300 batteries. Okay, so this 300 batteries is what? It's the working process inventory. Okay, but here what I'm asking is not just working process inventory, it's the total inventory. Besides working process inventory, we also have the raw material inventory. Okay, keep in mind. Raw material inventory. Okay, oh, sorry. This is raw material. This is not finished product. This is raw material inventory. Let me change this. All right, raw material inventory. That's why this is 300 plus 8,000. In total, you have 8,000 batteries, right? 8,000 batteries as your asset, okay? But here, remember, I also asked another question. How much are these battery boards, okay? So you already calculate the amount of inventory of the battery, right, in your inventory. But this is not the inventory value, okay? This is not the inventory value of those batteries, right? In order to calculate the inventory value in dollar, all right, for those batteries, you need to basically use the amount times what? Times basically the dollar value per battery, right? Dollar value per battery. Here, I give you some information about this. The average cost of each battery is $45. Okay? So at least For every battery, it is worth $45 before you sell it, right? Before you sell it. So this is $45. So that's why here we know that in total we have 8,300 batteries times the $45. Basically, every battery is worth this amount. So in total, you see the total inventory value is $373,500. All right. So that's why you see the total inventory amount and total inventory dollar value. Those are two different things. Right? This is about battery. This is about the dollar amount. Those are two different things. Okay. So in questions, keep in mind you are clear about what I'm asking. All right. If I'm asking inventory amount, you should use this. This is the correct answer. If I'm asking inventory value, dollar value, this will be the corresponding answer. All right. Although they're actually related, but they are not equivalent. They're not equivalent. All right. Now, give you another example. Okay. As long as actually you understand class exercise, you see that actually, although I changed everything about the context, but the inside of applying, basically the little story is exactly the same by using this class exercise 2. Okay. Let me give you some sense about it. Now, class exercise 2. Safety regulations require that the time between airplane takeoffs, all right, will be at least 3 minutes. All right. When taking off, the runtime of the airplane on the runway is 45 seconds. Okay, you see, this is 3 minutes. This is 45 seconds. Okay, by just looking at this two, you can already feel that okay, some units are different. Okay, probably when I do some calculation, I need to make the units the same. Okay, so keep that in mind. Okay, now planes are on average waiting 4 minutes and 15 seconds for takeoff. On average, there are 15 planes taking off per hour. How many planes are either on the runway or waiting to take off? Okay, this is actually a very simple problem. All right, so still, right, you are basically calculating the planes are either on the runway or waiting to take off. Okay. If we view plane as the inventory in this production process, okay, although we know that this is not the manufacturing process, but if we apply to this specific scenario, right, basically we're talking about what are the planes are in process, all right? This is actually very similar as the working process inventory, right? Here we basically just apply to this plane situation. We're talking about how many planes in this process, but the underlying logic is exactly the same. Right? So in order to get let's say the number of the planes in this whole process, okay, what kind of information we need? Still, remember, the inventory equals the throughput rate times flow time. Okay? What is the throughput rate? Basically, throughput rate is the speed, is the how fast, right? It's how fast for in this specific example, it's basically represent how fast this plane, okay, will go through this whole process, right? How fast? How fast? Okay, here we have two information. Which one you think is about the speed of this production process? What is which one is the speed of this whole production process? Or we say this is not a production process. This is, let's say, this takeoff process. This one. Okay. On average, there are 15 planes taking off per hour. Why? This is the speed. So actually, by just looking at the unit, you already get some clue, right? The speed normally would be the number. The unit of the speed would be number over time. That's why here you see this would be the number, the plane over what? Over hour. That's the speed, right? Here, if we go back to class exercise 1, what is speed? The speed would be 200 cars per 8-hour shift, right? So car per 8 hour, and then we transform it to car per hour, right? But no matter it's car per 8 hour or car per hour, you see this is the number per time. That would be the speed, right? Speed is exactly showing that information. That's why here, on average, there are 15 planes taking off per hour. This would be the speed. Okay, so basically that's why here throughput rate is just 15 planes per hour. So basically it tells you every hour 15 planes can take off. That's it. That's the speed, right? How fast is production line. Okay, all right. Now another key information is about the flow time. It's about the flow time. Okay, so let's look at this flow time. Okay, first of all, in this specific context, what are counted? Okay, what are counted as in the flow time? You see how many planes are either on the runway or waiting to take off. Okay, so basically, if you are running right now as a plane, if you're running, it's counted within the flow time. If you are waiting, yes, it's also counted within the flow time. Okay, what is the takeoff time? You see, when takeoff, the run time is what? 45 seconds. Okay, 45 seconds. Okay, now this time should be included within the flow time. All right, is this the only time? No, this is the run time, but we still need the wait time. Okay, here we say that safety regulation requires the time between takeoff, will be at least 3 minutes. Okay, but it doesn't tell us what is the specific wait time. At least it needs 3 minutes, but it doesn't tell us what is the specific wait time. Okay, here this information tells you something. Planes are on average waiting 4 minutes and 15 seconds for takeoff. Yes, this is information that exactly that we want, right? Because what we want basically the flow time that represents the run time and also the waiting time. That's it, right? 45 seconds already give you the run time. This 4 minutes and 15 seconds will give you the takeoff time. The waiting time, right? So basically, the run plus waiting time to take off basically is this summation of these two different time. Okay? Can you directly add it up? No. Why? Because this is 45 seconds. This is 4 minutes and 15 seconds. Okay? That's why here you have to transform them to the same unit before you can do, simply add it up, right? So here, that's why you see when we do the flow time, this is 45 seconds, right? 45 seconds divided by 60 is what? It's a corresponding minutes, right? It's a corresponding minutes. 4, basically just this 4 minutes, right? 15 seconds divided by 60. 60 is corresponding minutes. So you see that actually after you transform the time within this parenthesis, all right, the result basically is just in minutes, okay, in minutes. But why we still divide by another 60? Why? Think about the reason. Why we divide by another 60 in order to get the corresponding unit, which is basically hour. The reason is very simple, because since finally we will calculate the throughput rate times flow time, right, in order to get the inventory. You see, the throughput rate, what is this corresponding unit? It's a planes per hour. It's not a planes per minute, it's planes per hour. That's why here, before we do the calculation, this specific unit should be hour, not minute. Okay? You see that actually do every calculation, we have to make sure that actually the units corresponding with each other. All right? Here, within the parentheses, or every information is represented by minute, but we have to divide by 60 in order to get hour, because this unit needs to fit for the thing right here. All right? The thing right here. That's why here, after we get 15 and also 1 over 12 for an hour, and then we do 15 times 1 over 12, which is 1.25. Basically means that, okay, in this whole, let's say, runway, or in this whole waiting procedure, there's 1.25 airplanes in line or taking off. So that would be we can view it as working process inventory, since we're talking about OEM stuff. But here, specified in this airplane situation, this basically are the inventory. Not inventory, but the airplane is waiting or is basically or is taking off during this whole procedure. Okay, very simple. So here I basically just give two simple example to illustrate the Little's law. Okay, very, very important. Little's law is very important to calculate your working process inventory. Okay, especially in the manufacturing process. Okay, so this will be the first video for chapter 6. All right, and we will continue to talk about some other important things in the second part of the chapter 6 video. See you guys.